So in this lecture, we're going to talk about variables. Now, variables are the building block of research. They are the factors that we are looking at in our studies. You might be wondering how we define a variable. The definition is going to blow your mind. Ready? A variable is something that varies. Anything that you can actually measure or observe. Things like frequency, duration, rate, intensity, number of bar presses that a rat gives, height, age, IQ, depression, victimization. These are all variables. They're all things that can change. Now, there's different kinds of variables. Some are independent and some are dependent. Maybe wondering what on earth I mean by that. Well, don't worry, we're going to go through it all. The independent, or you'll often hear this called the predictor variable, is what gets manipulated by the experimenter. If you can remember that the independent variable gets manipulated, you're a quarter of the way there. Independent variable, manipulated. I want you to remember those two together. Okay, so this is what the researcher is changing or doing something to. This is often going to be things like dosage of a drug, type of treatment, like CBT or talk therapy, intervention strategies. Basically, what we're doing is we are changing levels of the independent variable. That's what we're manipulating. And then we want to see if or how it impacts some other variable. Now, this other variable is what we would call the dependent or outcome variable. The dependent variable is measured. I want you to remember IV manipulated, DV measured. If you can do that, you're half of the way there. We don't do anything to the dependent variable. As the researchers, our job is not to touch the dependent variable. What we do is we change the independent variable and then we check the dependent variable to see if that change in the independent variable resulted in any change to the dependent variable. Basically, the DV is not manipulated. It is just measured to determine the effects of the manipulation. Some common dependent variables are things like health, behavior, feelings. So say I were doing a study on blood pressure. Maybe I would make two different groups of participants, and one group, I assign them an exercise plan, and the other group gets a medication. What am I manipulating? What am I changing in this scenario? If you guessed the type of treatment, you'd be spot on. I am manipulating the treatment that the different groups are getting. Either they're getting medicine or they are getting exercise. I, as the experimenter, am controlling that. Any idea what the dependent variable is? So I'm changing the treatment, I'm changing the exercise or the medication, and then I want to see if that affects something, the dependent variable. Any guesses? Blood pressure, right? I want to see if exercise impacts blood pressure, and I want to see if medication impacts blood pressure. Notice I'm not doing anything to blood pressure directly. I'm changing exercise, I'm changing treatment, and then I just measure the blood pressure to see if the treatment had any effect. Now, sometimes there are sneaky outside factors that can kind of mess with our research. These are called confounding variables or confounds. These are outside influences that change the effect of the relationship between the IV and the DV. Let's take the earlier example with blood pressure. We know that the independent variable is treatment, the dependent variable is blood pressure. But there's a lot of things other than treatment, other than exercise and medication, that might impact blood pressure. Can you think of any? I'm thinking about things like stress, mental health, physical health, family history. These are all going to impact our blood pressure that are unrelated to our exercise levels and to our medication. These are confounds. If we don't account for them, then how can we be sure that the change in the dependent variable or blood pressure is due to the manipulation, the independent variable, the treatment? Maybe it's actually related to how stressed the person is. So I want you to always ask yourself, I call it the confound question. The confound question is, what factors other than the independent variable might impact the dependent variable? I'll say that again because that's really important. You'll hear me ask it a lot. What factors other than the independent variable could impact the dependent variable? In the context of this example, we might say, what factors other than treatment might impact blood pressure? That's the question you're always going to ask yourself when you have a, excuse me, when you have a research question. You want to think about what potential confounds there might be. Now, you may be wondering what we can do about these pesky confounding variables. The answer to that sort of goes beyond the scope of this class. I'll give you the nutshell version. Basically, we control for them. Control variables are ones that we hold constant, and we do this using statistical methods that we don't need to talk about in this class. Basically, when we control for a variable, what we're saying is, let's assume that this variable is the same for all people. So if we're controlling for stress, we're saying, let's just assume that everyone in this study has the exact same level of stress. Or let's assume that everyone in this study is the same age or the same gender or has the same health background, whatever it is. Again, this is a statistical technique. You don't need to know how to do it. I just want you to know that it exists. So we control for as many variables as we possibly can. This helps with that confound problem. It's taking all of those potential confounds and saying, let's just sort of level the playing field. Problem solved, right? That addresses the issue of confounds. To an extent, it can certainly help. The problem is that we can never account for everything. We will always miss a potential confound, whether because we haven't thought of it or just because you can only assess so many things in one study. Eventually, your participants are going to start to get tired if you're asking them too many questions. And this goes back to my prove rant from last lecture. No study is perfect. We can never account for everything, which is another reason why we can't use the word prove. Let's take an example here. So here we're asking whether the type of liquid that we give to a plant has an impact on the plant's health. Now, the first thing we need to do is think about, well, what do we mean by health? There's a whole lot of different ways that we can conceptualize the health of a plant. Maybe we can think about the greenness, right? The color of the leaves. We can think about the fullness or the lushness of the leaves. We can think about the height. How tall is the plant? And so in the example here, we're talking specifically about height. Well, I would ask you, what is our independent variable? But it says it on the slide, so let's just roll with that. The independent variable here is the liquid that we use to water each plant. And if you look on the bottom, you see there's a couple different scenarios. One level of the independent variable is soda, one is juice, one is water. So that's what we are manipulating. That's what we are changing between these three plants. Now, our goal is to keep everything else the same, as similar as possible, as consistent as possible across the board, minimizing those confounds so that we can see if the change in the independent variable or the type of liquid impacts the dependent variable or the height of the plant. With me? I want you to ask the confound question. What factors other than the IV might impact the DV? Take a second and see if you can put that in the context of this example. What factors other than the type of liquid might impact the health of the plant? And so I'll ask you to actually consider what some of those factors might be. I have a couple examples here on the slide. The type of plant, right? An African violet requires very different care from an orchid, very different care from a cactus. The size of the pot, the amount of liquid, right? If you're only giving a thimble full of liquid, that's a very different measurement than if you're giving an entire cup full. We want to keep that as similar as possible across the conditions. Temperature, sunlight, the type of soil, all of these things are going to be relevant in understanding the height of the plant. All potential confounds. These are things that we want to make as similar as possible. So we want all three of these plants to be kept in the same temperature, given the same soil, given their liquid at the same time of day in the same quantity. right? Similarity across the board is the way to go. Let's do an example. I want you to pause the video and identify the IV, the DV, the confound question, and a couple potential confounds. So students at a university were split into two groups. Each received a different text for a psychology course. One group got a traditional textbook. The other one got an interactive textbook on a tablet computer. After the course, the final exam grades between the two groups of students were compared. So pause the lecture, I think about the IV, the DV, the confound question, and any potential confounds. So the independent variable here, or what we're manipulating, is the type of textbook, right? The traditional textbook or the interactive textbook. That's what we as the researchers changed. The dependent variable is the grades. That's what we're measuring. We want to see if the textbook, the type of textbook, plays a role in the students' grades. So the confound question would be, what factors other than the textbook might influence students' grades? There's a whole lot of correct answers here, but if you came up with things like the amount of sleep they got the night before, whether or not they ate recently, interest in psychology, their reading ability, their background knowledge, these could all be potential confounds. Another one, Dr. X does a study with 3 groups of 10 students each. Each group consumes a different amount of caffeine, high, medium, and low amounts. Dr. X then measures all of the students on how well they did on a concentration test. So pause it, think about IV, DV, confound question, and potential confounds. IV here is caffeine. Don't be confused. Now you're seeing different levels. So whereas in the past, we've had 2 levels of the independent variable, or the textbook, the interactive textbook and the regular textbook, now we have 3 levels, high, medium, and low caffeine. Doesn't change anything for our purposes. Caffeine is still the independent variable. The dependent variable, the outcome variable, what we are measuring is the concentration. How well do the students concentrate? Now we have to ask ourselves what factors other than caffeine might impact concentration. Again, a lot of right answers here. If you are thinking things like the amount of sleep they had, how much food they've eaten, we know that the amount of food in your system can impact caffeine sensitivity. Caffeine sensitivity, some people are highly sensitive. My husband has to have coffee in the morning or he is an absolute zombie. Whereas I'm a natural morning person, so if you give me coffee in the morning, you will have to peel me off of the ceiling. One more. A researcher is interested in the relationship between social media use and mood. So they randomly assign half of the participants to browse their favorite social media app for 5 minutes, while the other half of the participants are asked to do nothing for 5 minutes. All of the participants then complete a questionnaire measuring their mood. Pause it, think of IV, DV, confound question, and any potential confounds. So here what we're manipulating is social media exposure. Are they browsing social media or are they doing nothing for 5 minutes? So that's what we're manipulating. What we're measuring, our outcome variable, our dependent variable, is then their mood. Does spending time on social media impact mood? We then want to ask ourselves what factors other than social media might impact our mood. What'd you come up with? I thought about things like their stress level, age, what kind of day you're having. If I'm already just having a really, truly awful day, spending time on social media is probably not going to change my mood all that much. And so there's a lot of different things you can come up with. Posted on Canvas, let me pull it up for you. I have this this activity that asks you, it gives you a little bit more practice. So coming up with the IV and the DV. I don't have the confound questions and confounds on here. You could certainly do that if you wanted to. I'll post the answers to this at the end of the week, but of course, feel free to email me if you have any questions. One thing that's really important to note in discussing research designs is random selection. And so this means that every person in the population has an equal chance of being able to participate in the study. Now, the population is every single person that fits your participant criteria. For example, if I were doing a study on women's ideas of feminism, my population is women, every woman on planet Earth. That is simply not feasible. There's no way I could collect data from every woman on planet Earth for a lot of reasons, starting with language barriers, ending with, access. It's also just not necessary. I don't need to ask that many women. So when we're doing a study, we pick a sample, a subset of the larger population, and we use them to be our participants. And we try to ensure that that sample is as generalizable as possible, that sample sort of encompasses the larger group as well as we can. Okay, so say I'm interested in women's ideas of feminism, and I survey all of you as my intro to psych sample, right? I ask all of the women in my intro to psych class how they feel about feminism. Can I generalize those findings to women everywhere? I hope you said no. If you said no, you'd be correct. That doing the study that way is not generalizable because I'm just asking a group of college women who are all in the Northeast Philadelphia area in the United States. So that doesn't mean we shouldn't do the study. It doesn't mean it's a bad study. It just means we have to be really careful about trying to apply those findings broadly. The experiences of a 20-something-year-old woman living in Northeast Philadelphia attending Holy Family University is very different than the experiences of an 80-something-year-old woman living in Nigeria. Okay, so we just have to be really careful about generalizing. Anyway, random selection is the best way for us to ensure that we have generalizability. It gives us a clear idea of what likely exists in the larger population. So if we don't select our sample randomly, we're introducing a confound. We can't say with confidence that our effects were due to the independent variable. Maybe they were just due to chance or luck. Let me give you another example. Say we're interested in employees' social media use on company time. You're the boss of a company. You want to know how much time your employees are spending on social media when they're supposed to be working. So you have 100 employees in your business and you figure 25 is fine. I don't need to survey everybody. Okay. There's 100 people in your population, everybody that works for you. But we can just take a smaller subset, a sample of 25. Okay. And so we'll get those 25 employees. We'll find out how many hours they spend a day on social media. Okay, so I'm gonna stand outside the door. Work starts at 9. I'll stand outside the door at 8:45, and the first 25 people that walk in the room, I'll hand each one a survey as they come in. When I run out of my stack of 25 surveys, I know that I'm done. I have 25 people. I'm good to go, right? Wrong. That's actually not a good sampling strategy. You guess why? Think about the people who come to work early. The first 25 people who walk through the door on a work day are probably the more motivated ones. They're probably the rule followers. They're probably the ones who are not going to spend much company time playing around on social media. Therefore, if I'm the boss and this is how I get my sample and I run my data and I say, wow, my employees really aren't spending much time on social media. That's probably not very true, right? It's probably underrepresenting the amount of time that people are spending on social media. So what I did there is by getting a non-random selection, I've skewed my results, and I'm making it more inaccurate when I'm trying to apply it to my larger population. What's a better way? So if we definitely don't want to do that, we definitely don't want to just stand outside the door and hand out surveys. A better way would be to toss all 100 names into a hat and pull 25 out at random. This way, because the population is 100 employees, each one of them has an equal chance of being chosen because I'm just tossing all of their names into a hat. Random selection is important for generalizability. Now, again, it doesn't necessarily, if you don't have random selection, it doesn't necessarily mean your study is bad. It just limits the amount of generalizing that you can do. In the first scenario, with the 25 participants that came in, 25 employees that came in first, I can't generalize those findings across the entire company. That only applies to those people. But in the second example, where I chose my sample randomly, I can apply those findings to the company more broadly. So it gives me broader, more generalizable data. Now, in the next lecture, we're going to kind of put all of this together and start thinking about one of the two major types of designs. We'll talk about correlational design and some of the ways that we can put variables together, and we'll start talking about some designs and methodology.